Hello! We are Tomoshibi Technology from Japan. I'm the leader, Junpei Saito.
My name is Tomohiko Ida. I'm in charge of robot arm.
I'm Yuki Tsuji, in charge of circuits, and I have developed more than 30 boards.
We organize hands-on workshop and present them at the conference. And we have raised over $60,000 to develop the robots on a large scale. Let's talk about the performance concept. We visualize the virtual worlds that only a computer can see. We have new experience for everyone. Therefore, we want to create a future where computer and humans collaborate and mutually serve as equals.
Let's talk about the design philosophy. We are committed to creating things ourselves to realize the ideas in our heads. All team members have knowledge not only in their area of expertise, but also in other disciplines. Each member collects newly learned techniques in a private wiki. When problems arise, we can find solutions from multiple perspectives. Let's introduce the amazing feature of our robot: fixing image to place, real-time visualization, lighting illusion, and perfect synchronization. These features provide a new experience.
Fixing image to place, progress, self-position estimate, and correct mechanisms make new extra experience. Moving display performs expression that the image is fixed to the place by synchronizing movement with the image. For this expression, accurate position estimation and movement are essential. First, position estimation is realized by using spring-loaded encoder wheel. The wheel is pushed to the ground, so it can measure correctly even if the ground is bumpy. Also, we created the system which can control speed for correct movement. We made motor driver to stably control powerful motor. If motor has encoder, through the value of encoder, the robot can control speed correctly. Moreover, each driving frame has suspension mechanism and is used to aluminum frame, so each motor can apply force to the ground and move more stably. In addition to this, moving display has camera. The robot recognizes and displays the color of the ball with this camera.
Real-time visualization. Display a large image using multiple LED ports.
Multiple LED ports can work together to display large images and visualize environmental sounds. High-speed communication is very important for the feature. A DC-DC converter is also important to make the LEDs shine brightly. Let's talk about communication. In this way, inputs from the laptop can be displayed in real time. LED port can also visualize ambient sounds. Onboard microphone makes ambient sounds visible. To light all the LEDs brightly, it was essential to make a strong converter. Many of the products on the market were expensive and lacked power. So after much trial and error, we built my own discrete converter. LED port can also be used for installation. We held this event at our high school festival.
Lighting illusion. The free rotation of motor with full-color LEDs create an illusion. This demo showcases one of the robot's capabilities, creating the illusion of a stationary light source by fixing the light direction. Controlling LED lights and arm movements allows for unique experiences. The tangle-free wiring structure, expanding the range of motion. Additionally, we developed a library for this feature. The LEDs enhance performance capabilities, and we've developed function to adjust lighting patterns. We track the robot's relative position during performances, enabling interactions. We created a hand mechanism using a rack and pinion system driven by a single motor. This robot has evolved through 3 major revisions and countless minor improvements since we began developing it last summer.
Perfect synchronization. All of our robots synchronize their colors and movement using RS485 and Zigbee. Synchronization devices is important for our performance. We developed our own protocol and collaborated with more than 50 microcontrollers. To begin, we had a lot of discussions about protocol. We developed a unique master slave protocol that passes over RS485 within each robot. Within each robot, we developed wireless communication using Zigbee. In order to connect more than 50 microcontrollers together, we selected from microcontrollers and made the board by ourselves. For example, the motherboards on all robots are tried and tested 4 times. I drew a schematic, a pattern diagram, and completed. These technologies allow all devices to work together in real time.
We focus on these 4 features: fixing image to place, real-time visualization, lighting illusion, and perfect synchronization.
These robots will be used to provide new experiences.
Please look forward to our performance. Thank you!